Hello students, good morning. So today in the digital system design we'll see the ROM, and today we'll implement the same in the Xilinx using the verilog HDL. Okay, so first again we know that the ROM is a simple read-only memory. We can't write any data, but only we can read. It is the non-volatile memory and it is used to store the binary codes for the sequence of instructions, and where only we can read the data, we simply use a word as a lookup table. So the ROM is also work as a lookup table. Now if we look at if we see the size of our ROM, then the size of ROM is defined with the 2 raised to n cross m, that n defines the number of inputs and the m defines the number of outputs. So according to that we have to set our inputs and outputs. So first today our first task is how we can implement the HDL code for the ROM. So let us move to the Xilinx. Today we are going to implement only the combinational circuit. So let me take one project, memory ROM. Verilog module, memory ROM. Okay. So here in the ROM, in the port list, we need the address, we need the data as output, and we need the chip selection. Chip selection, if chip is selected, it will perform the operation, otherwise not. So let us assign the direction, input, address. Let's assign the input of 2-bit, the input chip selection of 1 bit, and output we are let's say taking 8-bit of the data. Now by using the behavioral modeling style, we are taking one always block, CS. If any change in the CS or the address, the code would execute begin. If the chip is not selected, then we want data as a 8-D00. This is nothing but the decimal number representation equivalent to 8-B 8 zeros. You can use any of that. Else, now we have the 2-bit address, so we'll use a case statement, case address. Here let's take 0, and the data is equal to 8-B01. If 1, then data, that is 8-B02. If 2, then data, that is 8-D03, and 3, data, that is 8-D04. Okay, we are ending our case statement. We are ending our 2 begin loops, and module is already there. Let us check the syntax by switching from implementation to the simulation. Let me click this, yes. Behavioral check syntax. Okay, so what's the error? Okay, so here we have to assign the reg as output. Okay, as we are using the always block, where we are defining our output as a data. Okay, now we are creating the test bench to apply the stimulus. So memory ROM TB. Now in the test bench, first what we need to do, we need to select our chip. So for the selection of the chip, I am selecting 2-B1. Okay, then here we are writing the different addresses, address of 0. Then let me take the same for the different other. One, two, three. Okay, let me check what addresses we have assigned. Okay, 0, yes. At the 0 we want output 1, at the 1 we want output 2, likewise. So let me save this. Let me check my test bench and let me run the output. Okay, let the observe the fit to view. Okay, when the chip selection is enabled, we are trying to observe from that. Okay, so when the chip selection is high, our address, when address is 0, 0, output is 1. When address is 1, let me zoom in more so we can see. Yeah, when the address is 1, output is 2, address is 2, output is 3, whatever we have assigned. So this is how we can observe the output of the ROM. It is nothing but a simple one combinational circuit. Okay, so next we'll see the BCD to 7 segment display as a ROM. Thank you.